Alright, so now we're going to talk about inverse functions. Okay, so the inverse function, which sometimes I will write the notation like this, f with a -1 here, that normally means the inverse. But essentially what you're going to have, or to figure out if an equation is an inverse of the other, or to find the inverse equation, is you're going to do the following. Alright, so let me go ahead and go to the bottom of this, and again you can read that example. It's a really good example actually. So to find the inverse, what you're going to do is you're going to switch. Remember, this is y is equal to 2/3 x minus 1. You're actually going to replace this y with an x, and then you're going to replace this x with a y. So essentially what you're doing is you're switching the places of x and y. You're going to switch that. And what you're going to do now is you're going to solve for y. So again, after this, you're going to solve for y. Alright, so to solve for y, remember we're going to add 1. So we have x plus 1 is equal to 2/3 y. Now to get rid of the 2/3, I'm going to have to multiply by 3/2. And if I do it to the right side, I have to do it to the left. Notice how I wrote a parentheses, because at 3/2, you're going to multiply all of this times 3/2. This is going to cancel, which is what I wanted, so I have the y by itself. So the inverse of this function is y is equal to, if I distribute this, I get 3/2 x plus 3/2, and remember 3/2 is the same thing as 1.5. Okay. Now the next part is that they want us to graph this, right? So we're going to go ahead and graph this. We're going to start off with this one, which is easier. So we start here, that's the y-intercept, and we're going to go up 2 to the right 3. So, and we can go also down 2 and to the left 3. So this is what this one looks like. Now the next one's a little bit tougher to graph, only because this is a 1.5, right? But nonetheless, let's just go up here. 3/2, remember that's 1.5, so we're going to go up to 1.5. Now the slope is 3/2, it's positive 3/2. So we're going to go 1, 2, 3 over 2. Right, and from here, notice that I'm in the middle. I'm going to go down 3 over 2. 1, 2, 3 over 2. And we're going to do that again. 1, 2, 3 over 2. So then right here, you have your two lines. This line was the inverse line. Okay. So essentially what you're going to find out, which is not really talked about here, but essentially what happens is that this right here, if I did it correctly, you should have a reflection over the y equals x. So if you have a y equals x is this line right here. If you did it right, this should look like a reflection over this line. Okay, you can sort of see that here. This right here is reflected. This part right here looks the same. So this is a reflection over that line. All right, so let's go over this next one right here, number 3. Now, on, let's see. On this one right here, we're going to do the same idea. We're going to switch the x and y. We're going to add the 2, so we have x plus 2 is equal to 1/4 y. Now to get rid of the 1/4, I'm going to multiply times the reciprocal, or just multiply by 4. That's the same thing. I'm going to multiply this by 4. So the inverse function would be y is equal to 4x plus 8. Now in this case, what I had to do, just because I don't really have a choice, is I'm going to say that each one of these lines is 2. Alright, not 1, but 2. So to graph the first one, we have, I'm going to go ahead and graph, let me graph the original one. So the original one is, let's see, -2 would be right there, and I'm going up 1, which is halfway now. So we're going up 1 over 4, which is right here. Up 1 over 4. Down 1 over 4. 1, 2, 3, 4. Oh wait, excuse me, oops, 4. And then down 1 over 4, okay. So that's what I got. So I'm going to go ahead and write this out, or draw the line, and I'm going to go ahead and do this one right here. This one's a little bit easier. So we have 2, 4, 6, 8. And the slope is 4, which means I can go up 4, which in this case I can. So I'm going to go down 4. So 2, 4 over 1. Excuse me, over to the left one because I want to keep it positive. So 2, 4 over 1. Let's see, 2, 4 over 1. Let's see, 2, 4 over 1. 2, 4 over 1. Okay. Alright, so that's what that would look like. Now remember, if you had a line, and this is going to be a little skewed just because of I'm not a great. This right here, let me draw with a different color if I have it. But one more time, like we talked about in the past, or in the last problem, the previous problem, this right here should be a reflection over the y is equal to x. So this little pink line that I have there, that should be like a mirror image from left to right. Okay. All right, let's go ahead and go to the next part, the back page. Okay, so on the back page, sometimes they're going to ask you to determine if two functions are inverses of each other. And to do that, it's actually a very simple process. What you're going to have to do is you're going to have to write, you're going to have to know f of g of x, if that's equal to x, and if g of f of x is also equal to x. Alright, so you have to have both. And that means that the two functions that, in this case, f and g, are inverses of each other. Of one another. Okay? So from the previous section, we should be able to know how to do this, but remember that f of g of x would be this, f of g of x. So in this case, this is function f, so I'm going to write 3, and instead of x, I'm going to input g of x. Now g of x is all of this, so I'm going to write all of that. So we have 1/3 x plus 1/3 minus 1. So remember, I'm doing this function, but all I'm doing is plugging in g of x right there. That's what g of x is. Okay. Now, when I multiply that out, I'm going to get x. 3 times 1/3 is x. 3 times 1/3 is 1 minus 1. So that's equal to x. So that checks out. Now, because you did that, you have to do it to the other side. It has to also work on the other, on g of f of x, right? So g of f of x, what are we going to have? Remember, g of x is 1/3, x plus 1/3. But instead of x, we're going to plug in 3x minus 1. And then we're going to do all the arithmetic here, and then hopefully we get x, and if we do, then they're inverses of one another. So 1/3 times 3x is x, 1/3 times negative 1 is negative 1/3, plus 1/3. This is just equal to x. So because they're inverses of one another, then, because you have x for both f of g of x and g of f of x, then yes, they're inverses of one another. Okay? Okay, so let me show an example of one that doesn't work. Alright, so one that wouldn't work, and this will be the last one that I'll do here. Remember, you have to do f of g of x. Alright, so in this case, f of g of x would be function f times 8x minus 12. Excuse me, I just messed that. Well, no, that's not right at all. Let me just start over. Alright, excuse me. So f is 8, and instead of x, I'm going to write something else. And instead of x, remember, I'm going to write g of x. Now, g of x is this function right here. So remember, I'm plugging in a different function here. Alright, so that function right here is g of x. So now I'm going to do all the arithmetic that goes with it. So 8 times 1/8 is x. 8 times 12 is 96. I'm going to subtract 12. Now, hopefully before even before you add the like terms, the important thing here to note is that this is not equal to x. So again, this is not equal to x. So therefore, if something is not an inverse, all you have to do is one of the functions. If it doesn't work for one, then you're done. So at this point you would say, no, this is not a inverse. They're not inverses of one another. Alright, so again, if they're inverses, you have to do both of them, and the f of g of x and g of f of x have to both give you x. And if they do, they're inverses. However, if you're trying to prove that the two functions are inverses of one another, and when you try the first function, in this case I picked f of g of x, and that gave me something that's not x, then you're done right there. You don't have to go any further than that. You can just say right there, they're not inverses of one another.